So this next topic is arithmetic series, right? Arithmetic series right there. Uh, on this topic, we are going to be adding all the terms of an arithmetic sequence, right? So for example, in this case, I had 10 plus 20 plus 30 plus so on until 120, okay? So in this case, I want you to see something, right? If I add the first term and the last term, that adds to 130, right? If I add the second one and the third one is 130, right? We know that that previous one right here is 100, right? So if I add that one and this one, that's 130 also, right? So if you can see on an arithmetic sequence, when you add the last two, then the two previous to those, and so on, they're going to add to the same exact number, right? So on an arithmetic series, that number is going to repeat uh, n over 2. Why n? Because n is that last term, the position of that last term. N is the position of that last term. So it's going to repeat half of those times, right? So in this case, when I have an arithmetic series, I can use the following formula to find, or let's call this instead of a, correct? Because it's the same, let's call it s of n. So the sum of the n terms equals n over 2 times the first one plus that last one in this case, right? So in this case, I need to find what's n, right? Now I'm going to use the formula for the arithmetic sequence. Remember, this a sub n equals a sub 1, the first term, times n minus 1 times the difference, right? To find what n is that one. In this one, we can imagine and approximate that value, but I want to show you on that one so you can see it. So I'm looking for n, but I know that a sub n, in this case, is the term that is in the position n, is 120, equals to the first one that is 10, plus n minus 1, and we know that the difference is 10. Right? So I'm going to subtract 10. So 110 equals 10 times n minus 1. And I'm going to divide by 10. So 11 equals n minus 1 plus 1. So n equals 12. Right? So that means that 120, sorry, is in the 12th position, right? Of course, in this one, it's easy to see that that's the 12th position, but I just wanted to show you because there are going to be some exercise that is not that easy just to identify, right? So in this case, I'm going to go the sum of the first 12 terms equals 12 divided by 2 times the first one, 10, plus the last one, 120, right? So this is 6 times 130. So that is 780. So if I add 10 plus 20 plus 30 plus 40 and so on to 120, I'm going to have that sum is 780. Okay. Again, on this next one, okay, I'm going to add 14 plus 17 plus 20 plus 23 and so on to 116. So you can see it's a arithmetic sequence because the difference between all of them is 3. So 17 minus 4. 17 minus 4 is 3. 20 minus 17 is 3. 23 minus 20 is 3. So now I need to find that n value up here so I know what term is that one. So I have a sub n, again, is 116 equals the first one, 14, plus n minus 1 times 3. So I'm going to subtract 14 on both sides. So 112 equals 112, no, sorry. This is 102. Now I'm going to divide by 3. 34 equals n minus 1 plus 1 on both sides. So n equals 35. Again, the formula for the sum of an arithmetic series is n over 2 times a sub 1 plus a sub n. So this is s sub 35, right? We already found that that's n on this one down here, equals 35 divided by 2 times 14 plus 116. So 35 divided by 2 times 130. So I have 35 times 65, 2,775. Okay, so my third exercise, again, I'm going to check if I have an arithmetic series by checking the difference, right? So 2 minus -5 equals 7. 9 minus 2 equals 7. 16 minus 9 equals 7, right? And 268 minus 261 equals 7. I'm not checking up here because I know that I don't know those numbers right there. Okay, so I know that this is an arithmetic series, right? So again, I'm going to start by finding this and what's that position of the 268. So 268 equals the first term -5 plus n minus 1 times 7. So I'm going to add 5 on both sides. So this is 273 equals to 7 times n minus 1. I'm going to divide by 7. This is 39 equals n minus 1 plus 1 on both sides. So this n is 40. So that means that the 268 is in the 40th position of this exercise. Again, my formula for the arithmetic sum equals s sub n divided by 2 times the first term plus the last term. So this is s sub 40 equals 40 divided by 2 times -5 plus 268. So 20 and 263. So 5,260. In this case, it has a theater has 50 rows of seats. The first row has 10 chairs. Each successive row increased by 2 seats. So we know it's an arithmetic, right? Because I have that is 2. It's going to increase by 2. So my first one, how many total seats are there in the first 3 rows? So this is easy, right? So 10. My second row should have 12, and my last row should have 14. So if we add all those 3 rows, we have 36 seats on the first 3 rows of that theater. Now, on the next one, I want to find the total seats in the theater, right? So first of all, I need to find how many chairs are there on my last row, right? It says that it has, sorry, on my last row right here on the 50th row. So for that, I need to use the arithmetic formula, right? Or sequence formula. So a sub 1 plus n minus 1 times d. So n again is the number of term of what position the term is, right? A sub 1 is 10 plus it's going up by 2, so 2 minus 1. Right, sorry, no, that 2 doesn't go right there. So n is 50 minus 1 times 2. So that means that 10 plus 49 times 2. So 10 plus 98. So that means that on the 50th row, we have 108 seats, right? So now I'm going to find my sum of the first 50 rows, or the 50 rows of the theaters. So I have 50 divided by 2 times 10 plus 108. So that's 25 times 118. So 25 times 118 is 2,950 seats on that theater. And that's it.